In this video, we will talk about managing and scaling Azure virtual machines. We will also talk about some backup and imaging regarding the virtual machines. This will be a fairly shorter video compared to the other videos that we have. However, it will still contain important information about how to use Microsoft Azure. Once you have your new Azure virtual machine configured as you would like it, you might want to create a clone of the VM. For example, you might want to create several more VMs using the exact same VM that you just created as a template. You do this by capturing the VM and creating a generalized VM image, something very similar to what a local administrator usually does when they have identical machines to be managed. When you create a VM image, you capture not only the operating system disk, but also any attached data disk. This is a slight difference between what you do locally and what you do on the Azure. Usually on a local computer, you really don't capture everything. The user data are not of that importance to you, and most of the administrators only care about the application installed and the operating system configuration themselves. The rest of them could be restored from any user backup or from cloud backups. However, when it comes to the Microsoft Azure virtual machine backups, you have to remember that both OS disks and all the attached data disk will be captured at the same time. For example, if you have a storage service on one of your VMs, that storage service will become a part of your VM image. And if there are some information that you don't want to be shared after deploying into a new machine, you have to erase them after you deploy to a new machine. Or another way is uh, just get rid of them before you actually do the sysprep. So when you capture the VM to use it as a template for future VMs, you will no longer be able to use the original VM. This is another important note. So the VM that you are capturing an image from will disappear and be disabled after you capture the VM. The original source is going to now turn into the image that you have. So the deletion happens right after capture is completed. So if you have any information there that you possibly may be very curious about not losing them, get a backup. Again, that virtual machine is going to be deleted right after the image is captured and the capture process is completed. For classic VMs, you will find the template image available for use in your virtual machine gallery in the Azure Classic portal. As of recording this video, there is no view available in the Azure portal for viewing images related to the Resource Manager VMs. Instead, you will need to look for the image in the same storage account as the original VM is residing at. So this address down here is how the path to your image is going to look like when it comes to ARM virtual machines. It's most often like that. However, there may be a slight change, but using that path, you can go down and figure it out. To capture a virtual machine, you basically need to use any of the three options that are available for managing Microsoft Azure besides using the portal. You can use the Azure PowerShell, you can use Azure CLI, or you can use the Azure Resource Explorer tool. However, again, for the classic VMs, you don't need to use these tools because the portal already has a view for that. Microsoft has provided a pretty nice step-by-step guide to show you how to create a managed image of a generalized VM in Azure, and the document is posted on docs.microsoft.com under the Azure documentation. As of now, the latest update of this document is September 26, 2018, which is fairly new. As I always remember and have seen, these documents usually don't get updated that quick, especially when it comes to this specific topic. But however, any document that you're using from Microsoft website and under the docs.microsoft.com, I recommend you not to create a local copy of those. Always refer back to those documents, as you never know when Microsoft is going to have the new patch or new updates or new changes in SLAs or so on. And you want to have the document which is up to date at any time. That is going to reduce the amount of hassle that you're going to go through. So let's go through this document pretty quick and see what you're going to get here. So pretty basic, some notifications about the fact that you need to enable your Azure RM alias if you're using the PowerShell or local command line. Then generally it talks about generalize the Windows VM using sysprep. I'm pretty sure you guys are familiar with sysprep from Microsoft Windows servers in the past. So that's exactly the same thing that you knew about it. Just sign into your VM, open your command line, go there, find the sysprep, which is under System32 sysprep, and run the sysprep exe, and go over there, choose the shutdown down here as a shutdown option so it turns it off. Just remember, when you turn it off, your job is not done. You have to go back to the resource manager within your subscription account and basically deallocate the virtual machine before you can create the image out of it. And all those steps are listed over here. Pretty good in creating these documents. I really am very satisfied with the quality of the documents that are available on docs.microsoft.com right now. The good thing is about these codes, you can actually click on try it and try the code to see how it works. However, if you click over there on the try it, it's going to take you to Cloud Shell. And if your account is a free account and it is expired, you possibly are going to have problem using it because Cloud Shell necessitates having a storage account already set up to use as a local disk. Anyway, suggestion is always copy the code and then paste it over there to avoid any type of typos that is so common when it comes to putting the command lines, and then move down. Basically, throughout this document, you will be guided through everything that you need. If you like to use this video, I know that the scroll is very fast over here, but we can pause it and go. But again, docs.microsoft.com is gonna help you with that. Remember that the image you create must be created from a VHD in the storage account, and also you're going to have to need some storage to store the final image you create. So these are the things that if you overlook at the end when you have your image, then you have to create that storage right away. And if you are on a free account, you may not want to go there, but if you're still willing to pay, that's what's going to happen. As with most of Azure services, Azure virtual machines follow a scale out, not a scale up model. This means it is preferable to deploy more instances of the same configuration rather than to add a larger, more powerful machine. The approach for scaling out VMs basically varies depending on whether you're working with a classic VM or a resource manager VM. When it comes to the resource manager virtual machines model, you don't typically scale out VMs in an automated way, which basically is what happens when you work with the classic model. Instead, a different Azure resource construct is used for scaling out VMs, which is called Azure Virtual Machine Scale Sets, which usually is abbreviated to VMSS. Virtual machine scale sets are relatively new Azure compute option for deploying and managing a set of identical VMs. What you need to do is to configure the VM image to be used and delivered to the Microsoft. Basically, this image should contain operating system configurations, softwares that you want to be installed on the VM, and so on. And then when you upload the image, you will let the Azure provision the desired number of identical VMs based on the provided image. The VMs in a scale set can run either a Windows or a Linux operating system as of today with the setting and availabilities of today. Scaling with VMSs does not basically require the pre-provisioning of VMs within an availability set like the auto scale for classic VMs. At the time that I'm creating this video, you can have up to 100 VMs in a VM scale set, which basically is more than enough for almost any type of use that you may have based on the current IaaS requirements. So it should be noted that when working with VMSs, there is no data disk available, as you may have with the regular Azure virtual machine. Data should be stored on either the OS disk or an external data store such as Azure Table, File, Blob Storage, Azure SQL Database, Azure Document Database, and so on. VMSs can be provisioned either via the Azure portal or the ARM template as we discussed in the other videos. Using the ARM template approach for working with VMSs is likely to be the most common approach because doing so offers many more features that are currently available in the Azure portal, and usually users are happier when they work with the portal. For instance, you can configure auto-scale roles relatively easily using the ARM templates. Such configuration is not yet available within the Azure portal for the ARMs, but for the VMs created in the classic mode, it is available. However, you can use the PowerShell to manage such needs. Once VMSs is created, you can have several familiar constructs within the VMSS availability set, such as load balancer, virtual network, IP address, and multiple Azure storage accounts. And you basically can make a decision on how to use those resources that you have within a VMSS. So VMSS are a preferred way to implement a scale-out compute cluster in Azure, no matter which model you're using. In fact, Azure uses VMSS to host higher level services such as Azure Batch or Azure Service Fabric and Azure Container Service themselves, and that shows that they trust the service more than any other possible service that they may provide. In the classic model, before VMs can be scaled, whether scaled out or scaled in, the instances must be placed within the availability set. This is something that ARM does not have as a requirement, and you can only see it in the classic model of virtual machine deployment. When determining the scale-out approach for VMs, it is important to determine the maximum number of VMs because that specific maximum number of VMs must be created, configured, and finally placed into the availability set that you will define for this purpose. When it comes time to scale out, the VMs within the availability set are used to fulfill the scale out needs. VMs within an availability set should all be at the exact same size, and they have to take advantage of Azure's auto scale feature. So you cannot have a D series and a G series within the same set and expect them to work in the auto scale. So it is crucial, again, for those servers to be exactly the same and be identical. Why use virtual machine scale sets? To provide redundancy and improve performance, applications are typically distributed across multiple instances. Customers may access your application through a load balancer that distributes requests to one of the application instances. If you need to perform maintenance or update an application instance, your customers must be distributed to another available application instance. To keep up with additional customer demand, you may need to increase the number of application instances that you run on different virtual machines. Azure Virtual Machine Scale Set provide the management capabilities for applications that run across many different VMs. Basically, the automatic scaling of resources that Microsoft Azure provides helps your load balancer to balance the traffic. Scale sets provide many features. First of all, easy to create and manage multiple VMs. When you have many VMs that run your application, it is important to maintain a consistent configuration across your environment. For reliable performance of your application, the VM size, disk configuration, and application installations and every single configuration you have should match across all the VMs you have. With the scale sets, all VM instances are created from the same base OS image and configuration. Later in this video, we will talk about how to create those. This approach lets you easily manage hundreds of VMs without additional configuration tasks or network management. Scale sets support the use of Azure Load Balancer for basic Layer 4 traffic distribution, and Azure Application Gateway for more advanced Layer 7 traffic distribution and SSL termination. These scale sets also provide high availability and application resiliency. Scale sets are used to run multiple instances of your application. If one of these VM instances has a problem, customers continue to access your application through one of the other VM instances and the minimal interruption. For additional availability, you can use availability zones to automatically distribute VM instances in a scale set within a single data center or across multiple data centers. One of the beautiful settings that Microsoft allows you to choose when you create an availability and a scalability set is that you can even decide which building number your VM instance is going to be on. For example, if in East US they have 5 different buildings, you can decide for each one to be in building 1, 2, 3, 4, and so on, which actually is going to help you with more customized scalability and availability sets. The other feature that makes using virtual machine scale sets appealing is that it allows your application to automatically scale as resource demand changes. So customer demand for your application may change throughout the day or week or peak seasons and so on. To match customer demand, the scale sets can automatically increase the number of VM instances as application demand increases. Then they reduce the number of VM instances back as the demand decreases and basically save you money. Auto scale also minimizes the number of unnecessary VM instances that run on your application when your demand is very low and people don't send any requests to your servers. While customers continue to receive an acceptable level of performance as demand grows and additional VM instances are automatically added again. This ability helps reduce cost and bring up the efficiency of your Microsoft Azure services. And finally, works at large scale. So scale sets support up to 1000 VM instances. If you create and upload your own custom VM images, the limit is going to be 300 VM instances. For the best performance with production workloads, you can use Azure Managed Disks and Premium Storage, which basically is going to add more to the expenses you have, but at the same time, it's going to increase the quality of service that you will provide to your customers. Scale sets are built from virtual machines. With the scale sets, the management and automation layers are provided to run and scale your application by Microsoft Azure. You could instead manually create and manage individual VMs yourselves or integrate existing tools, code snippets, and whatever means you have to build a similar level of automation without using Microsoft's skill sets. The table you're looking at right now actually outlines the benefits of scale sets compared to manually managing multiple VMs yourselves. So think about scenario first. So add additional VM instances. When you do manual group of VMs, there is a manual process to create, configure, and secure the compliance of those. While where you're using the virtual machine scale set, all of these are going to automatically happen. So it automatically creates from central configuration, and you really don't go through the hassles that you go when you manually manage it yourself. From the perspective of traffic balancing and distribution, manual process to create and configure Azure Load Balancer or Application Gateway or anything in the VNet that you create can be compensated by the virtual machine scale set that can automatically create and integrate with Azure Load Balancer or Application Gateway without your interference. Regarding the high availability and redundancy, same story is applicable. When you manually create availability set or distribute and track VMs across availability zones, you basically have to have a local professional IT manager to take care of that for you. While when you use the virtual machine scale sets, automatic distribution of VM instances across availability zones or availability sets happens, and again, it doesn't need your intervention. Same again about scaling of VMs. When you need to scale VMs in the manual set, you need to manually monitor the Azure automation. Remember, you can create code, you can run programs to take care of that for you. And there have been instances that the code that users have created has been so good that Microsoft has adopted those codes. However, it all goes back to how professional your team is in order to really manage something that Microsoft is managing behind the scene, and it should not be your concern. When you go to that level to create a code that can manage the load balancing even better than Microsoft does, that means you technically are maintaining the Azure infrastructure. And I believe there is really no need to go that far while you're using cloud services. There is no additional cost to the scale set, which is important. So basically, you don't pay anything to use these services, which again is going to defeat the enthusiasm for manually group VMs and manage the scalability of them yourself. So you only pay for the underlying compute resources such as the VM instance, load balancer, or managed disk storage, which in the manual mode you still will be paying for those. The management and automation features such as autoscale and redundancy incur zero additional charges over the use of VMs. Okay, let's see how we can actually create a virtual machine scale set in the Azure. So to do so, of course, you need to log into your Azure portal. As you remember, the address is portal.azure.com. And then what we want to do is we want to come here and create a resource. So I'll click here, and then in the search box of the resources, I will search for virtual machine scale set. So virtual, and this is what I'm looking for. So this is going to bring up the Azure virtual machine scale set for me. And of course, you can read it over here. It tells us that Azure Virtual Machine Scale Sets let us create and manage a group of identical load balanced VMs. The number of VM instances can automatically increase or decrease. Again, remember, we don't scale up, we scale out. And that's what it is reminding us. So scale set provides high availability to your application and allow you to centrally manage, configure, and update a large number of VMs with virtual machines as scale set. You can build larger scale services for areas such as compute, big data, container workload, and so on and so on. So if you like to read it later, go there. Rather than that, just click on the create. And here we need to enter a name for the virtual machine set name. I'll call it availability set, and that's it. So the operating system disk image is basically what disk images I want to use over there. Remember, you can only use one of these guys because in the availability set, as we said, all of them should be identical. Okay, and then for the sake of this one, I go with Windows Server 2016 Data Center. Then we have to enter the desired resource group name. It can be any resource group name. I'm putting test VM for CCSF. As you can see, my free trial is over here. We will discuss that later. And then after the resource group name, you need to enter your identity down here. So the location, like always, is East US. Availability zone, you can choose zone 1, 2, or 3. I'll go with zone 1. And username, let's say test username. There you go. And when you put the password, remember about the password complexity. It should be at least 12 characters long and meet 3 out of the 4 complexity requirements. So one lowercase character, one uppercase, one number, and one special character. You need to have 3 of those actually in there. So make sure you are choosing the right password. So I already have a password from my CNIT admin in the past, but since I don't remember what it is, I'm gonna create another one. So let's see if I can come up with the complexity. Okay, let's do this. And it still wants me to go more. There you go. And I got it over there. This usually creates a little bit of hassle for everybody. And the instance count, the minimum is 2. I'm choosing 2. I already have the standard DS1 version 2 chosen for the data center that I created for the sake of this class in the past. Deploy as low priority. I don't want to do it as low priority, and basically it's not even available for this size, but for the premium sizes you can do that. And then on managed disk are not supported with the availability zone. So basically on these two, based on the type of subscription and the type of size that I chose, I don't have no option. I wanted to do auto scale for me. If I do auto scale, as you can see, you can choose the minimum number of virtual machines in the uptime. So that is telling the Azure that, hey, at least one instance should be up, and I want one instance there for sure, because that makes sense. Without that one instance, you're not going to have no service. And then the maximum number of VMs is for the purpose of cost management. So I'm telling it to go up to 10 servers if need be in this instance. I'm going to change these before I move on, but just to explain what these guys mean. For the scaling out, you can decide on what CPU threshold percentage you want to scale out. Let's discuss this a little bit. So when you're using your computer, you can always go to the task manager or third-party applications to see how your resource usage is. And you have noticed that the 2 critical resources that you use for the locally used computers is basically CPU and RAM. And the virtual machines and the VMs in the Azure, we'll look at the CPU threshold, because RAM can be increased automatically behind the scene without the hassle for you. And in this case, we are telling Azure at 75% threshold, switch and scale up by 1. So number of VMs to increase by is 1. So basically I started 1. If my CPU usage scales up to 75%, then I'm going to switch to 2. And then if those two, each one arrives at 75% again, I'm going to scale up again and again and again. And then you talk about the scale in over here. Basically, again, what is the threshold to scale down? At this case, the default value is 25%, and you say, if I'm not using more than 25% of a CPU on a VM, turn that VM off for me so I don't pay for that. Remember, if you consider this, and at this point the other server is at 75, when it scales down over here, it's going to scale back up because of that 75%. So it all depends on the specific pattern of the traffic you have. This usually is not the case. You usually don't have the case that one of your servers is handling like 80% and the other one is only at 20%. This is very rare, but mathematically and theoretically, if that become the case, so you scale down and then again scale back up once again, and this goes back and forth. Uh, this type of case basically means you don't have a good load balancer set up in place, and your load balancer is not able to manage it very well. When you fully automate this with Azure, the load balancer of the Azure actually takes care of this matter. So you usually are at a kind of distributed load between all your servers. So it is not the case that one of them is 25 and the other one is 75%. So you usually have two of them at 50, two of them at 40-ish, two of them at 30-ish, and then when two of them get to the 20-ish, then first one reaching 25 is going to be out, and now you have one server with about 20 to 30% of the CPU workload, and that is the real case. So that mathematical theoretical case really never happens, and if that happens, that means the load balancing is wrong within your availability set. And then coming down here, we have the networking part down here, which actually talks about the load balancer and the application gateway that I have. Scrolling down here, I can choose the load balancing option. It could be application gateway, load balancer, or none. If you're running a mobile app or something off of the VM, suggested is application gateway. If you are doing multiple services, then load balancer is the better one, and you need to choose any application gateway if you go with that. So in this case, within my resources, I actually don't have an application gateway already set up. So I click it on none, so it doesn't ask me for that. So remember, because this is a default, you may get an error when you create this about, hey, this one is not set up. So I put it in none because for right now, I just want you guys to see the steps you take in order to set up your virtual machine scale set, and nothing more than that. And then a public IP address per interface is off. You can, of course, turn it on and set it up to whatever you want. For the virtual network, I only have one VNet, and for the subnet, I only have one, which is a default subnet, and those are getting set up. So basically, everything is pretty clean and clear and ready to go. So the only thing you need to do is click on create and move on. So for more hands-on practice, please check the hands-on labs. And as we discussed before, we're using microsoft.com/hands-on-labs, and simply search for Advanced Azure Virtual Machine and Compute to launch it. Okay, so I am on the Microsoft Hands-On Lab site. As you can see, the address is microsoft.com/hands-on-labs/self-paced labs. Pretty simple. And then what you want to do is you want to search for Advanced Azure Virtual Machines and Compute. virtual machine and compute. There you go. And when you search for this guy, this lab is gonna pop up. So the number for the lab is AZ1 quadruple 05, and you simply click on launch, and you will arrive at this page. Uh, if this is your first time coming here, before this page, it may show you three options to log in. And of course, you want to look at the Microsoft Prospect customer, the free one, to get in here. So you come down here, click on I'm not a robot, so launch, and we're going to start our session. This preparation sometimes takes up to 4 or 5 minutes, as it says, and be patient, and you will be here. So before I click on start, I want to remind you that this page is gonna open a pop-up, and if you have your pop-up blocker active, that's not gonna let this page actually start the lab for you. So make sure that your pop-up blocker is deactivated, or this page actually is exempt from the pop-up blocker of yours. So as you can see, this lab is going to take about 2 hours for me, and I'm now opening it up. There you go. As you can see, I have access to Microsoft Azure interface. Let me just readjust the interface pretty quick. And here you go. Now we have everything that we need to have. So on this side, we have the virtual machine lab instructions. Basically, just follow the instructions over here. And then what you see over here actually makes you able to do anything as far as those are listed in the instructions over here. And go through the get started, go through the guide. Remember, there's some stuff that if you want to do here and they're not listed under the lab requirements over here, it's going to ask you to switch to your own normal account and go from there. So pretty nice and neat. It's going to help you go through the lab as it is instructioned within the scope of the instructions with no problem. Okay, now is the time for you to go and take advantage of this hands-on experience and learn more. This concludes this video, and thank you for watching.